The first thing we'll talk about in this chapter is all sorts of properties of exponents. There are a bunch of different properties that you need to be aware of, and we'll just walk through each of them. However, you'll probably need to come back to this section another time or two, just because there are a lot of them. The first one's called product of powers. So let's say you have a to the m times a to the n. What you're going to do is you're going to say a to the m plus n. So in a real example, let's say you have 3 to the 6 times 3 to the 2nd. What that really means is 3 to the 8th, because you get 3 to the 6 plus 2, which is 3 to the 8th. Let's say you have x to the 4th times x to the 6th. Your answer is going to be x to the 4 plus 6, or x to the 10th power. So when you multiply two like bases together, like a times a or x times x, you will add up the exponents. The second example is when you take a power to another power. So let's say you have a to the m power, and you take that to a power n. In this situation, you will multiply the exponents together, a to the m times n. So in a real example, let's say you have x to the 3rd to the 8th power. And really what that means is x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd 8 times. But you don't need to write this out. Now you would add all these together, because you know when you multiply them together you add, but you can just multiply 3 times 8 and you'll know you have x to the 24th power. One more example of this would be 2 to the 5th power squared, and all that means is 2 to the 10th power, which is equal to 1024. This rule also applies if you have two different things inside of parentheses. So let's say you have x squared times y to the 3rd power, and that's taken to the 5th power. What you're going to do is multiply each of those exponents by the 5, and you'll get x to the 10th, y to the 15th. Moving right along, I'm really trying to make these videos as short as possible. Let's talk about what happens when you have a negative exponent. And sorry if my writing is a little sloppy today. The pen on my tablet stopped working, so I'm having to use my finger. So we have x cubed times x to the negative 7th. Of course, when you multiply two exponents together, you will add the exponents, add them, and you'll get x to the negative 4. Now, anytime you have a negative exponent, what that means is it's on the wrong side of a fraction. You need to put it on the bottom. X to the negative 4 really means x to the negative 4 over 1, so you'll flip that around and you'll say 1 over x to the negative 4. That's your answer. And now that exponent is not negative anymore. Another example of this is maybe if you see something like 7 to the negative 4. Of course, what that really means is 1 over 7 to the 4th power. And you could evaluate that as well. A final example of this is maybe something where you have 1 over a negative exponent, like 1 over 2 to the negative 3rd power. What that's really screaming at you to do, it's saying, hey, I'm a negative exponent, I'm on the wrong side of the fraction, put me on the top. And so what that really means is 2 to the 3rd power over 1, or just 2 to the 3rd power. So if you see a negative exponent, if it's on the top, move it to the bottom. If it's on the bottom, move it to the top. Something else you need to know about is anything to the power of 0, so a to the 0 is equal to 1. 3 to the 0 equals 1. 10 to the 0 equals 1. This fuzzy koala to the 0 power equals 1. The next rule we'll talk about is the quotient rule, and all it says is a to the m over a to the n equals a to the m minus n. In a real world example, like x to the 7th over x to the 4th, it says 7 minus 4, and you're left with x cubed. In another example, let's say the bigger number is on the bottom, so t cubed over t to the 9th. What this says is 3 minus 9, t to the negative 6, which really means 1 over t to the 6th, because the negative sign is telling you it needs to go in the bottom. But you could just look at this and see, okay, there's 6 more t's in the bottom than on the top, so what you're going to be left with is 6 t's on the bottom. But, following the formula, you'll subtract 3 minus 9, get negative 6, then move it to the bottom, just like this. Let's say you start out with negative exponents, like 6 over negative 3 6 over negative 6. The first thing you want to do is flip those around, because as soon as you see a negative exponent, the first thing you do is put it on the right side of the equation. So the negative 6 goes on the top, and this negative 3 gets moved to the bottom. Now you can subtract those and say what we're left with is 6 to the third, and 6 to the third is 216. Alright, let's say we have a really complicated example like x to the third, y to the negative 2z, all over y to the fourth, z to the negative 4. The first thing you should do is move the negative exponents to where they go. So x cubed stays on the top, that y to the negative 2 goes to the bottom. So we'll move that down there. We move the negative 2 down there, so we have this 4 plus that 2. We have 6 y's on the bottom. The z to the negative 4 goes to the top, and now we have 5 z's on the top. And that's our answer. Alright, just one more example with the quotient rule. I know there's a lot, but there's a lot of different things they could ask you. So b cubed over b to the 6th. Let's say all of that to the negative 2 power. That negative 2 needs to get distributed to both of those, so we get b to the negative 6 over b to the negative 12. Then we're going to flip those signs, because if it says negative, it's yelling at you to put it on the other side. So b to the 12 over b to the 6. Subtract those, 12 minus 6, to get b to the 6th. And that's your final answer. In the last part of this video, we'll look at multiplying and dividing numbers in scientific notation, such as 9 times 10 to the third times 5 times 10 to the second power. In order to multiply numbers in scientific notation, you'll first multiply the numbers in front, so 9 times 5 is 45. Then you'll multiply the numbers in the back, so 10 cubed times 10 to the second power. Because those numbers have the same base of 10, you're just going to add the exponents together to get 10 to the fifth power. So 45 times 10 to the fifth power. However, scientific notation requires that the number in front is between 1 is greater than or equal to 1 and less than 10, so between 1 and 10. So we have to change this number to 4.5, and when we do that, we'll increase the number on the 10 to show that the real number is larger than what this 4.5 looks like. So 45 times 10 to the fifth gets changed to 4.5 times 10 to the 6th, which is your final answer for the first one. Now let's look at an example of division, which is the problem I've written above. So in division, we're going to do much the same thing. We're going to split that into two parts. We have 1.1 divided by 5.5 times 10 to the negative third divided by 10 to the negative 8. So 1.1 divided by 5.5 is 0.2, or 0.2. And then 10 to the negative third over 10 to the negative 8. We can swap those positions, because since the exponents are negative, they're trying to get to the other location. What that actually looks like is 10 to the 8 over 10 to the third. And then to divide those, you will subtract the exponents, 8 minus 3, to get 5. You don't actually need to swap that like I did, 10 to the 8 over 10 to the third. If you don't and you just subtract the exponents, that's the rule. You can do minus 3 minus negative 8, and you're still going to end up with positive 5. Now this number, 0.2 times 10 to the fifth, is still not in scientific notation, because this number is not between 1 and 10. We have to move the decimal to the right one space, and since the real number is smaller than what it appears, we have to decrease the number, so it's 2 times 10 to the fourth.